Okay, good morning. As Tim said, my name is Jim Wallace and I run the emerging segment within ARM. One of the key focuses there is on green technologies. And my talk this morning will focus on intelligent energy management. Just before I step into that, I just want to talk a little bit about ARM. Oops. ARM supplies the world's leading semiconductor players with IP. We provide the technology that lies at the heart of low-power digital products. A good example of that is the mobile phone space, where we dominate that space, from voice-centric phones, where we have one core, up to the latest, say, Apple iPhones or N95 phones, where we have 4 or 5 cores in there. It's all about developing cores that are low power, enabling low power. We've brought that technology into the home consumer space. Our products also are in the likes of Blu-ray products, set-top box products, TVs, and then to move into, let's say, intelligent motor design, which is enabling low power white goods in terms of washing machines, dishwashers, and so forth. But we also have a very strong presence in the wireless marketplace in terms of Wi-Fi. If you open a Wi-Fi, the likelihood is you will find an ARM product in there. And finally, we have recently started to move into the smart meter space, and our products basically are fitting in there as well. We have to date shipped 1.5 billion cores into the marketplace. I think next year we will surpass the 10 billion mark. One of the key things that makes ARM strong is our connected community, our partners. And those partners are the silicon partners, the OEMs, software, service providers. It is a whole community of people developing solutions around the ARM architecture. And this is really just a graphical explanation. I guess you can find your phone in there somewhere. Let's maybe just talk about what I came here this morning to talk about. This is really looking at energy management and how ARM is enabling that. We see 3 key areas for energy management. One is we talk about the power plant and moving this energy from the power plant to the home and doing that efficiently and reducing losses in the transmission line. The second one is where I will focus the presentation is on efficient energy usage, both within the home and also within commercial buildings. And finally, and I think we've touched on a number of times as well, is renewable energy. And that being either, let's say, hydro or the newer form, solar, wind, and biomass. But I think the key point I want to make here on this slide is that all 3 areas need to have equal focus, not just in one area. So just kind of touching on, let's say, energy efficiency, and we see that basically as a 5th fuel, in addition to the traditional coal, nuclear power. Again, as was touched on, let's say, in terms of China and the emerging countries, there is a growing need for energy. All you have to do is look at, let's say, the power plants that are being built in China. I think there's 1 a week at this point in time. The equivalent population of Europe will move into China cities in the near term. That they would bring an insatiable appetite for energy. Clearly, we need to reduce energy, and this is really just giving you, let's say, 2 examples that if we can reduce this energy by 10%, we can make a significant reduction in our carbon emissions. We can save almost 1.5 times the carbon emissions from the UK households, just by saving 10%. So if we look at the opportunities that exist for us, I think the first one is in commercial buildings. That offers us one of the biggest opportunities. These buildings consume over 40% of the total energy. And the key areas there really is in HVAC or heating systems, lighting systems, and lighting alone, takes up 14% of the energy. In industry, products that are developed in industry consume somewhere between 25 to 50% of the energy. And motors, and it's a key area, consume 60% home. Again, it's a little bit more fragmented, but potentially we're looking at, let's say, consuming energy of somewhere between 20 to 25%. And again, it's similar to the commercial side in terms of lighting and temperature control are the key users. But as we move forward, consumer electronics is becoming a major demand for energy. And by 2020, it could, let's say, account just under 50% of domestic usage can be in consumer forms. So what do we need? Clearly we need to look at things, and just taking a quote from Al Gore, but I think it's a good one in terms of we can't continue the way we're going today. We need to change. One of the key areas and what ARM brings to this space is new technology. So it's looking at developing products from the ground up, so with energy efficiency in mind. So let's look at, let's say, some of the things that we could envisage going forward. In terms of buildings and intelligent buildings, there are three key areas really. There's the structure of the building itself, so there's the intelligent skin, there's the building systems, so there's the control functions, and there's also the IT and equipment within the buildings. If we can, let's improve the structure, we can significantly reduce the thermal dissipation and improve the comfort within the building. By, let's say, improving, let's say, the equipment within the building and ensuring that equipment runs at optimum efficiency, again, we can reduce energy. What ARM sees, whether it's in the home or in buildings, is intelligence everywhere. So these are smart sensors connected either wirelessly or wired together, feeding that information back to, let's say, a set of actuators that control the environment and make them pleasant environments to live in. Renewable, I've touched on already, but non-polluting, what do I mean by non-polluting energy sources? If you look at these sensors and going forward, we will have, in the future, thousands of these sensors in the let's say, commercial buildings or let's say moving into home. The key change that I see moving is move from battery to batteryless, looking at energy harvesting techniques. And again, ARM, through, let's say, using this low power technology, fits very nicely with that trend going forward. We also see buildings being able to generate their own energy and feeding some of that energy back onto the grid going forward. Not quite there yet, but it is coming. I think one of the key things that needs to change as well is consumers' behaviour. I think this will take a little time in terms of consumers tinkering with control systems, getting used to that, the idea that the building controls itself rather than actually always going and changing either the thermostat settings and so forth. That will take a little time, but it will come. So if we look at the connected home, again, what we see is consumer devices, be they TVs, set-top boxes, also IT, PCs. It is growing, and there are more and more of these devices in the home. These devices are becoming more and more connected together. They are using more and more energy. ARM is playing in that space in terms of trying to reduce that energy, both from, let's say, a dynamic power consumption and also a standby. As I said at the beginning, we're also moving into the smart meter space, and that enables basically the utilities to be able to, empowers the customer to be able to move their energy usage around, so that which will get them cheaper electricity, but also help the utility companies as well with their peak demand areas. AMI is one area. This is really the advanced metering infrastructure. There's also, let's say, AMR, which is the advanced meter solution. Examples of this really is the AMI example. There's a whole range of people who have already implemented smart metering. If you just look at Italy, they have a power line system. Sweden, I think, have a combination of power line and wireless areas. These are big, areas. I think Italy, talking about, let's say, replacing 30 million meters. So it's big business opportunities. But again, it's empowering the customer. So it's enabling the customer to look at their energy usage immediately. They can see by, let's say, switching on and off products how they can affect the bill. They can also set their max and min guard points in terms of temperature, helping the utility companies, but also reducing their energy bills. We've seen other Whirlpool ran a trial that just finished last year, where they put energy-saving devices into the home, a number of different types of homes. And what they found that, let's say, over the 2-year period, or let's say over per year, they were able to save, on average, somewhere around the $230 mark. Now, that, from a consumer point of view, it's nice to have in your back pocket, but it enables you to buy maybe 4 or 5 energy-saving plugs that fit at the back of, let's say, your appliances. Or if you take it further forward from that, is the utility companies could supply those devices free of charge, and that would enable them to save potentially a new bill of a new power station, which is anywhere between somewhere between $500 million and $2 billion, depending on what type of power station you're looking at. But let's, in terms of ARM, again, when we look at, let's say, these intelligent buildings, intelligent homes, where ARM fits very nicely is in terms of, let's say, the central smart controller. But not only there, when you look at, let's say, that smart controller would take in, let's say, user preferences, what tasks are required to be done. Looking at, let's say, various sensors in terms of measuring, let's say, temperature, CO2 within the building, looking at outside maybe temperature sensors, or taking, let's say, input from the web, and also linking that back into the smart meter. So you can see that in terms of the bottom 3, the interior conditions, the sensors ARM plays very nicely in there in terms of low power. ARM also plays on the other side in terms of the actuators. So whether that's changing the, let's say, the awnings, shadings, changing, let's say, your lighting systems, or controlling your HVAC. Again, ARM products fit very nicely in that area. So, as I said, tomorrow's energy efficient buildings require several processing functions at all levels, let's say, of the infrastructure, and ARM fits very nicely in that area. We talked about sensors, and I kind of mentioned wireless sensors. Just want to really very touch on this. They are coming. There are companies already today that sell wireless sensors. There's companies already down in I think Southampton, Perpetuum have developed, let's say, a sensor. Sorry, not a sensor, but energy harvesting based on vibration. So there are many different sources that you can use to harvest energy, be it solar, vibration, or rotation. The nice thing about these systems is you don't need to replace any more batteries. And 2, when you're helping the environment by not throwing away those, let's say, batteries, and reducing your costs in terms of maintenance. And again, ARM fits very nicely in this space as well, from a low power point of view, because when you're harvesting the energy, it is exceptionally low power you're talking about, and let's say our microcontrollers coming again from the mobile phone space fit nicely into that space. If you look at the kind of modern products today, we're all very used to compact fluorescent lamps, which have given us a significant improvement in power over, let's say, the traditional Edison light bulb. Just around the corner, and it's already happening in commercial buildings. We have solid-state lighting, and again, that gives us a significant improvement in power again, with a significant increase in lifetime. But ARM will play the control of that But more so, I think ARM plays in the middle space in terms of intelligent motor control, where we can significantly improve the energy efficiency of white goods by over 70%. Also, we can see, let's say, our products fitting into such devices like the IntelliPlug, and I believe, let's say, outside there's also this other device as well I'll show here today. And within the home consumer space, in terms of set-top boxes, all you can do is look at set-top boxes today. The amount of power that they take, it's unbelievable, in terms of whether it's on or off, it's still on. Devices to say, in terms of your DTD box or your set-top box, when it's on, 7 watts, when it's off, 6 watts approximately. When it's a satellite box or a cable box, when it's on, potentially it can be 23 watts. When it's off, and this is one of the best in the marketplace, is somewhere around 16 or 18 watts. Which is crazy. When you compare, let's say, in terms of a mobile phone, the worst case of a mobile phone when it's on, it's about 3 watts. When it's off, it's 10 milliwatts, or in standby. So there's a lot of work to be done here. I think ARM can bring a lot of the knowledge and intelligence that it has to the space. And then we have, let's say, a number of government organizations, helping consumers with labeling. This is really just taking what I said in terms of the set-top box space. So that if we, on the right-hand corner, the left from your side, if we continue as is in terms of, let's say, the standard box, DTD box, we will end up, let's say, consuming, let's say, 20 power stations with the power demands being on all the time, or a complex box, almost 50 power stations. Sky has started to do something, I think working with Pace last year, launched their standby solution where after a certain time at night time, the box would go into standby or low power mode. What I've done is I've extrapolated that information and shown us what would happen if everyone, or every box in the world did this. Again, you'd have a significant reduction in power plants. And then what I've tried to do is look at, well, if you started to use some of the techniques that we have in mobile phone space today, where you would potentially just cycle on and off and turn off a lot of the functionality that you don't need, you could significantly reduce it even further. And this is just a graphical, again, showing you in terms of what, let's say, in terms of from a power point of view, ARM can keep, let's say, the world's mobile phones powered with just 350 megawatts of energy. If you compare that, let's say, to the PC market, you're looking at, let's say, 95,000 megawatts of energy, significantly more. So again, there's a lot that ARM can bring to energy efficiency. And this is just some of the products. We've talked about the cores. We have a whole range of cores from, our Cortex M3 as far as our multiple core, where you have, let's say, 4 cores in one, running at a gigahertz, giving you very high performance, but also enabling you to trade off power versus that performance. We have a range of libraries. This is really all the standard blocks that you need to put together in an IC. Together with our power management kits, offer significantly lower power. Our intelligent energy management and dynamic voltage frequency scaling technology enable you to reduce your dynamic power. Going forward on a roadmap, what we have is we have invested in Swazik. It's a French company that develops silicon and insulator. Again, that gives us, significant power reduction over existing CMOS technology. This is just bringing us back again to the motor example, as it's so important in terms of power. ARM, as you move forward with these motors, they require more and more complex control algorithms. So traditionally, they have been, say, on 8 and 16-bit cores. No longer are they useful. They need to move to the next generation cores, which is, say, the ARM 32-bit. The example I give here is the M3, which is finding a very nice home in this marketplace. But it's not just that. It's the low power electrical libraries that we have. It's the tools that we have around these cores, which significantly reduce the code size. And I think the key thing, and I mentioned it already, is the Connect community. It's working with our partners in the Connect community to offer a seamless design environment. there. I think really what I want to say here today is, armed together with our connected community partners, our goal really is to develop, let's say, next generation technologies